Welcome, Math Crew. Welcome to a puzzling activity with a sequence. My sequence is rock, or, door, shovel, parrot. Rock, or, door, shovel, parrot. This sequence extends on forever and ever, and we could number the elements of the sequence like I've done here, 1 through 10. But eventually, I'm going to get around to asking you about certain entries of the sequence. And if I asked you something like, well, what would be the 13th entry of this sequence? I think you would know how to figure that out, and it would be fairly straightforward. But what if I asked you about the 434th entry? Or what about the 1,105,721st entry? That might take some puzzling. So that's where we're headed today. If we wanted to find the 434th entry in this long sequence, we could extend the sequence forever and ever off to the right. We could draw them out or label them somehow and then figure it out the very longhand way. But there should be a more clever way of getting at this if we work on this a bit. I find that when I think about these sequences in long lists that extend off to the right, that I get overwhelmed by how many things there might be happening. So I'm going to reorganize my sequence in a different way. I'm going to organize my sequence vertically instead of horizontally. So notice that I still have my sequence numbered, and I still have the same order: rock, or, door, shovel, parrot. But they're separated into chunks that repeat. So I have elements 1 through 5, and then I have elements 6 through 10, and then if I had enough pieces, I could put in elements 11 through 15, I could put in elements 16 through 20, and I could keep going. And now I'm going to leave it to you to puzzle through how we can figure out which entries will be oars versus shovels or parrots. I would give you a hint that you might want to look down here at the entries that end the chunks of your sequence and see what you come up with for puzzling with that. Then when you have an idea, then you can return to these two entries and see if you can figure out what they would need to be. Once you have this figured out, you can change your sequence so that it has any number of elements in a chunk repeating. You can also switch from toys to letters to symbols, and you can also switch to bases, numerical bases raised to powers, and consider what the units digit would need to be. And that's where I'm going to head next. Before we get to the next patterning example, here are a couple of reminders. In a number like 5,372, if you wanted to identify the units or ones digit, it is the 2 in this case. It is the digit that is one place to the left of where we understand the decimal point to be in a whole number. We need to know about the units or the ones digit because you're going to be asked about that. As another reminder, if you were going to do this computation by hand, there are a variety of ways to do it, but it's important to note that if you are doing it in the old school algorithmic way, you would do 8 times 1 and you would get 8, and then you would do the rest of these multiplications, 8 times 6, 8 times 5, and 8 times 3, and you would write in their results to the left of this first 8 that you wrote down. So whatever those are. I'm not going to worry about what they actually are. And then to finish the problem, you would need to come next to the 9 in 498, and you'll do 9 times 1, and you'll get 9, but when you write it down, it goes in the tens location. So there's nothing written underneath this 8 that we got from the first product ever when we complete this. So that when you go to add up all of your results, the units digit for the product will be 8. And this is true for any two whole numbers that are multiplied together. Their units digit will be the product of the units digits in the original numbers. We will need to know that as well. All right, so the task having to do with patterning. Let's keep our parrot, move the page up a little bit. Let's say that we wanted to know what is the units digit for 7 to the 593rd power. And you might think, oh, this doesn't have to do with patterning. I will just get my calculator and I will ask it for 7 raised to the 593rd power. It will give me an answer and I will write down that units digit. Tell it enter. And it says, oh, no, this is too big. We're having some overflow problems. So there's not a way to get this from the calculator at this time. For the units digit, it must be that your instructor has made a mistake in asking you this. If the calculator can't do it, how can you do it? Well, the answer is you're more clever than your calculator. All right, here's a way to start this. If we started and we did them by hand, 7 to the 1 would be 7. 7 to the 2, remember 7 to the 2 means 7 times 7. That's 49. 7 to the 3, your calculator will handle 7 to the 3. And if I go ask my calculator for 7 to the 3, it tells me that that is 343. And maybe you forgot what we were up to, but we were looking for ones digits or units digits. So first we had a units digit of 7, and then we had a units digit of 9, and now we have a units digit of 3. And then we keep going. 7 to the 4th. Well, if we do 7 to the 4th, we will end up at 2,401, and the units digit here is 1. And you might be thinking, oh my, I cannot possibly do this to the 593rd by hand. But just wait, let's see what's going on. We knew 7 to the 1 was 7. To get 7 to the 2, we would take this answer and multiply by 7. So we got 49. To get 7 to the 3rd, you take the previous answer and multiply by 7. Note that 7 times 9 would be 63. That's where this 3 for the units digit comes from. To multiply by 7 again for 7 to the 4th, this units digit of 3 gets multiplied by 7. That would give us 21, indicating that our units digit should be 1 for the next answer. So if I am right, when I take this answer for 7 to the 4th and I multiply by 7 to get 7 to the 5th, I should get something that has a units digit of 1 times 7, which is 7. So let's check it out. 7 raised to the 5th. It's supposed to have a units digit of 7, and it does. 16,807. 7 to the 5th, 16,807. There's my units digit. I've already had a units digit of 7. I was keeping an eye on that, and so I've stacked it back up here in chunks, kind of like the toy sequence. For 7 to the 6th, you can ask your calculator for that, but you can also remember, oh yeah, 7 times another 7 is going to give us a units digit of 9. And I'll just put dots over here. I don't have to figure out the whole thing. And that tells me that 7 to the 7, if we multiplied 9 by 7, we'd have a units digit of 3. 7 to the 8, 3 times 7 would be 21 for a units digit of 1. You can verify this on your calculator, but it should work. And this pattern will repeat and repeat and repeat on and on forever, and this would allow you to find the units digit for 593 if you can take a look at our stacks of the repeated pattern in the units digit. When we did the toys, we had stacks of 5. This time around, we have stacks of 4 in the sequence before we repeat. So when we do continue this, if we came over here to 7 to the 9, 7 to the 10, 7 to the 11, and 7 to the 12, we should get units digits of 7, 9, 3, and 1. And I will leave it to you to puzzle out how to figure out what the units digit will need to be on that 593rd power of 7 based on this kind of patterning. And then if you're in my class and we come back together to meet, we'll be talking about this as a group, taking the ideas that you have and using them as a group.